So number 4 is it's a good question because it's a thinking question and there's some algebra in there. And they want to know whether or not the lines are parallel. So we need to test the A to see if the A is the same in both. If the A is the same in both, then they're probably parallel. There is an exception, and the exception is if the A and the B are both the same, then actually the line's not really parallel. It's the same line, right? If the line has that slope with that y-intercept and another line has the same slope with the same y-intercept, then it's the same line. But if they have different slopes, we know for sure they're not parallel. So we'll see. So for this one here, I have a 4y, so I'm going to have to divide eventually. But first I have to get rid of this addition. So subtract 14x from both sides of the equation, leave me with this, which I then divided by 4, leave me with this. So the slope for this one is negative 3.5, and the b is 6. And you'll notice over here I got a b of 6 also, same initial value. That's no big deal. I'll show you what that looks like after. It depends on what happens with the slope. So this one, less work to do. The y is almost isolated. All I have to do is this division here. So I did that and I got this. Now you're going to notice this slope is negative 3.5. This slope is positive 3.5. That's not the same slope. Right away, these lines are not parallel. The fact that they have the same b just means that they would look, if you wanted to know, they would look something like this. Right? The b is where they cross the y-axis. So one of them is a positive 3.5 change, the other one's a negative 3.5 rate of change, and they would have crossed right there. But certainly they're not parallel lines. And you know that because the slopes are not the same. We'll take a look at question number 5 in a second.